Hello, my name is Becca Schraub, and I am a associate at Casa Urban Design Company, and I will be presenting on Casa Aibonito. Casa Aibonito is located in San Juan, Puerto Rico. It is designed for a middle-income family and is 150 meters squared in area. It contains 3 bedrooms, 2 bathrooms, and can house up to 5 people. It also has an attached garage and a large backyard. Because it is in Puerto Rico, there is no heating, but there is air conditioning. Moreover, all of the appliances will be electrical rather than gas. And the goal of Casa Aibonito is to have it EDGE certified, so a green building. And in order to be EDGE certified, there must be a 20% reduction in energy, water, and embodied energy in the materials from the base case. And the base case is based on a similar sized home in a similar climate and economy. So for energy, Casa Urban Design Company suggests that the clients install external shading devices. According to EDGE, these must be provided on the building's exterior, and the intention is to protect glazed elements like windows and doors in order to reduce radiant solar heat gain. So we not only recommend overhangs on south-facing windows, but also shutters. And overhangs are really good for windows that are south-facing or near the equator for the angle of the sun, and shutters are preferred in east and west and can be closed to help reduce solar gain. Also, overhangs and shutters will both be useful in the case of a hurricane, since Puerto Rico does get hit by hurricanes occasionally. Having the ability to put shutters over your windows to keep them from breaking in the middle of high winds is critical. Casa Urban Design Company also suggests that the home have a domestic hot water system. Specifically, we suggest an air source heat pump. Because there is an air conditioning unit, the heated air that is being removed from the house can be used to heat the water. This greatly reduces energy consumption in the home. And the intent is to reduce fuel consumption and carbon emissions in general. According to the International Finance Corporation, an air source heat pump can have a reduction of at least 25%, but up to 50%. Casa Urban Design Company also suggests that the client install renewable energy on site. According to EDGE, this requirement must displace fossil fuels, not just be in addition to fossil fuels. And Casa Urban Design Company suggests enough photovoltaic solar panels on the roof to reduce the energy consumption by 25%. This map shows the different energy uses according to what type of energy is being consumed. And on the left we have the base case, and on the right we have the improved case with the overhang, shutters, renewable energy, and water systems. So you can see a great decrease. Next, moving on to water, Casa Urban Design Company suggests that the home have water-efficient landscape irrigation. So according to EDGE, this means that it must use less than 4 liters per day per meter squared. And the goal of it is to reduce municipal water supply, as well as the maintenance of fertilizers and herbicides that go into maintaining a lawn. So we suggest that the client use native and low water using plants, drought tolerant plants, and grasses. And the goal of that is to reduce water use to 1 liter per day per meter squared. Our second water recommendation is to install a rainwater harvesting system. So this would collect water off of the roof of Casa Aibonito, and according to EDGE, it must reduce municipal water use for the project site, and the intent is the reduction of municipal water supply. So according to my calculations, the rainwater harvesting system could collect over 73,000 liters from the rooftop of Casa Aibonito. And as part of the system, it would have dual piping so that it could distribute water to toilets and washing machines. And with this system specifically, the water could also be used for irrigation outside for the 1 liter per day per meter squared of the landscaping. As hurricanes are prominent in Puerto Rico, so is the lack of electricity and water supply after said hurricane. And so creating systems in this home that allow the occupants to have electricity and water whether or not the municipal supply is there was one of our clients' important design suggestions. And so we took that into account, and these are our suggestions for the water. And while the rainwater could not be used for potable or cooking or drinking, it still can be used for flushing toilets and doing dishes and washing clothes. So this chart shows that there's a 44.72% reduction in water supply when compared to the base case. And you can see that a large amount of that reduction is in the irrigation due to the drought-tolerant species as well as the rainwater harvesting system. Now, to reduce embodied energy, we looked at the materials for the construction of the home. And for the exterior walls, according to the EDGE, the goal is to reduce embodied energy, and any design recommendation has to actually be implemented for it to count. So Kalesi Urban Design Company suggests that honeycomb blocks with 40 to 60% voids be used, and that will have external and internal plaster for it. The benefits of using this type of exterior wall is that it goes up very quickly and there's less material because of the voids, so thus it's less embodied energy as well. Moreover, the honeycomb walls have improved thermal performance because of the air gaps, and no mortar is necessary, so there's less embodied energy in that as well. It also has a high impact resistance, which is critical when thinking about hurricanes and high winds, so it can take things hitting it without falling over. Another suggestion that Kalesi Urban Design Company has is for the interior walls to use cement fiber boards on metal studs. According to EDGE, for interior walls, it must reflect the type of interior wall actually used and reduce embodied energy. And for Kalesi Urban Design Company, our goal was to provide or suggest a strong material that won't rot, twist, or warp, and our suggestion does just that. So cement fiber boards on metal studs are more stable because they're on metal as well as cement, and there's no rotting, twisting, or warping. Moreover, they're self-colored, so there's no need to paint, which saves embodied energy as well as labor for that. And they're easy to install, so it can go up quickly. On the left, you can see that the final energy use, assuming all of these design recommendations are implemented, is 603 kilowatt hours per month. The operational carbon dioxide savings is 1.93 tons of carbon dioxide per month. The energy savings is 5.34 megawatt hours per year, and the water savings is 284 meters squared per year. The embodied energy savings is 259 gigajoules. And while the base utility cost is $214 a month, these recommendations reduce that cost by $115 a month. Overall, it will cost about $8,000 to implement these design recommendations, and it would take 5.7 years to pay that off based on their benefits. On the right, you can see that based on the material-specific recommendations, there's a 42.53% reduction in embodied energy, and a lot of that is in the interior and exterior walls. So for operational energy and carbon emissions, according to EDGE, it must fund the reduction or recapturing of carbon emissions, specifically for carbon offsets, which is Kalesi's urban design suggestion, is that the owner purchase offsets of 2.9 tons of carbon dioxide per year, which is what EDGE is saying is the improved case of carbon dioxides. Moreover, the intent is to reduce net impact of building construction as well as operations, so by purchasing these carbon offsets, it would continue year after year as well as just from the building and construction phase. And according to EDGE, you must have a signed contract that proves you are buying carbon offsets every year. All right, thank